My name is Professor ADSUL'S. Today we start a problem that is built up I section. Here the problem is provided. Then in this problem we have to find out minimum radius of gyration. Then this is the top flange which is built by the other plate of dimension. The width is 80 mm and total depth is 20 mm. This is the web section of 10 mm width, and this is also bottom flange which is built by other plate which has a dimension that is width is 80 mm and depth is 10 mm plus 10 mm 20 mm. Then before finding minimum radius of gyration, in the first step we have to calculate moment of inertia about x-axis. Here I-axis that is equal to BD cube upon 12 minus BD cube upon 12 for PQRS section minus BD cube upon 12 for PUVW section. This is the whole section, that is BD cube upon 12. Means if you want to find out moment of inertia about the x-axis, the formula for rectangular section that is BD cube upon 12, that is for whole section. Here whole section, that is ABCD is already represented by ABCD. Then minus BD cube upon 12 for PQRS minus BD cube upon 12 for TUVW, this portion. Then first of all we find out B, that is the width of total section, is already provided 80 mm. Capital D, this is 150 plus 10 plus 10, 150 plus 10 mm plus 10, total depth of whole section is 170 mm. Then small b for PQRS, this is for rectangle ABCD, for rectangular section PQRS, small b is total width of section 80 mm, then 80 divided by the 80 minus 10, that is equal to 70. 70 divided by 2, that is 35 mm. Then depth will be, this is total depth is 150. 150 minus 10 minus 10, then 130 mm. Then for section, for rectangular section, UVW, PUWV, B is same 35 mm, B is also same 130 mm. Then we put up the value in the power equation. I-axis moment of inertia about x-axis. We put up the value. Capital B is 80 into capital D is 170 cube divided by 12 minus small b is 35 into 130 cube divided by 12 minus small b is given 35 into 130 cube divided by 12. Then After calculation, we get the value 19.934 into 10 raised to 4 mm raised to 4. This is a value for moment of inertia about x axis. In the same manner, we calculate the values of moment of inertia about y axis. Iy, that is equal to, formula will be dv cube upon 12 for section 1 plus dv cube upon 12 for section 2 plus dv cube upon 12 for section 3. Okay. Then there are three sections. The whole built-up I section, which is divided into three parts of section 1, 2, 3, and it is represented by as a section 1, 2, 3. The formula for rectangular I section, the moment of inertia about y axis. T is the depth. The depth for first section, that is 10 plus 10, 20 into B is 80 cube divided by 12, bracket complete. This is for section 1 plus for section 2 D is 130 into B is 10 cube divided by 12. This is for section 2. Then in the same manner, for section 3, D is 80 into B is 10 plus 10, 20 into 80 divided by 12 for section 3. Then here, moment of inertia about y axis. After doing calculation, you do the calculation, then you get the value of moment of inertia about y axis. That value will be 1.715 into 10 raised to 6 mm raised to 4. This is value for moment of inertia about y axis. Once we find out the two values for moment of inertia about x axis and y axis, then which value will be less as compared. If you compare moment of inertia about y axis and moment of inertia about x axis, the minimum value for moment of inertia, therefore minimum value of moment of inertia, if you compare two values, then Iy is I minimum value, because this value is 1.715 into 10 raised to 6 mm raised to 4. Then once we find out the minimum value for moment of inertia, then we find out moment minimum radius of gyration. Formula will be K minimum, that is equal to under root I min upon A. Then here area, that area is total area A1 plus A2 plus A3. Then area for section 1, 80 into 10 plus 10, 20 plus area for section 130 into 10. Then area for section 80 into 20. Then 1600 plus 1300 plus 1600. Then total area 300 plus 1300. Then total area will get area, addition of area for section 1 plus area for section 2 plus area for section 3. Then we get total area. Then we put that value in the equation 1. Then finally we calculate minimum radius of gyration. It is represented by kp, that is under root I minimum, that value already find out, 1.715 into 10 raised to 6 divided by total area 4500. Okay. Then after calculation, then calculated value for minimum radius of gyration will be 19.53 mm. Okay. This is our aim or target we want to achieve. Then here I will repeat how to achieve, how to get our required aim. Then this is built up I section. In the built up I section, in the first step we calculate moment of inertia about the x axis according to formula for moment of inertia for rectangular section. Then in the second step we calculate moment of inertia about y axis. Once we find out the values of moment of inertia about x and y axis, then compare both the values of moment of inertia about x and y axis, then find out minimum value of moment of inertia. It is represented by I minimum, that is equal to Iyy. Then here Iyy is the minimum value of moment of inertia. Once we get the minimum moment of inertia, then find out minimum value for radius of gyration. The formula will be under root I minimum upon the total area. Then how to calculate total area? Total area is the addition of three sections, area of three sections. It is represented by A1 plus A2 plus A3. For A1 we consider section 1. It is a width 80 mm and it is a depth 20 mm for section 1. 80 into 20 plus, in the same manner here in the figure section 2 is the base section of the beam. The width is 10 mm and this depth is 130 mm. Then 130 into 10 plus this is the bottom flange of the I section beam. Then here this is a width 80 mm and this is a depth 10 plus 10 20 mm. Then the area for section 3 will be 80 into 20. Then we put up all values in the given formula for total area, that is equal to A1 plus A2 plus A3. Then we get the total area. Then we substitute that value in the above equation, that will be considered 1. Then we put up that value in the equation 1. Then we get the minimum radius of gyration. That is our aim of this problem. We have to calculate, we have to find out minimum radius of gyration. That value will get 19.53 mm. That is the problem. Here that section is called as built-up section particularly. Why it is called built-up? Because here the one more plate will be added or attached or connected to the top flange as well as at the bottom flange. Then that's why that I section build I section is called as built up I section. Here that is the way to calculate the minimum value Thank you for watching the video.